Hi there.
Hey, Kiko. Good morning.
Good morning. How are you doing, Jose?
I'm very good. I'm excited about today, and thanks everyone for joining us.
Cool. All right. Let's start by introducing ourselves, shall we?
That sounds excellent.
Okay. So my name is Christian Reese, or better known as Kiko inside Canonical. I have a background in software engineering, long-time open source contributor, did a lot of work, Mozilla DevTools, etc., and have been at Canonical since 2004. I run the public cloud business for Canonical, and I'm responsible for the relationships that we have with Microsoft and driving creation of new products and also joint customer engagements with Microsoft. I'm based in Seattle here with my family, but I'm originally from Brazil. I've been here since the end of last year in these sort of crazy times, and there's a link here on LinkedIn if you want to see more about me.
That's awesome, and I'm Jose Miguel Parrella. I'm a program manager in the office of the Azure CTO here at Microsoft. I'm also in Seattle. I've been using Linux for about 20 years, Debian developer, devs, apps, that's all the stuff that I love, so I'm really excited about today. And it's actually our second time doing a webinar together, but today I think it's going to be fun-filled with demos and some very interesting things around Ubuntu Pro.
So yeah, so let's start by talking just a bit more about Ubuntu Pro. So historically, Canonical has produced Ubuntu as a free operating system, which everybody knows and loves. And with Ubuntu Pro, we worked with the clouds to package into it all the Canonical services and offerings that were available independently before. And so it's a single VM offer. You click or launch from the API, and then you get all the services from Canonical activated. What's Ubuntu Pro about? It's about production. It's for professional use. It's security focused. It includes a number of facilities that are going to make operating Ubuntu easier and make the scope of security coverage broader. The one thing at the highest level, which is interesting, it comes with a 10-year maintenance guarantee. We built the LTS. The first one is in 2006, 606, and 606 was the first time that we first delayed the release by 2 months. We did the release in June, and it's the first time that we were saying we're going to put forward a release which is built for production, enterprise, and server use. And 606, we introduced this concept of the LTS, 5 years. Pro now, in 2020, includes this concept of 10 years. So 10 years of maintenance, 10 years of guaranteed security, 10 years of API stability. So it's a really big deal for us there. And in terms of complementary features, it includes live patching for the kernel, there are Fips certified components and images, it comes security hardened, and there's patch coverage for 28,000 sources. It's about 60,000 binary packages that you can install on Ubuntu and get security coverage for that. So it's a big deal for us, I think a big deal for Microsoft having as a partner in helping drive this forward.
Yeah, absolutely. We won't have time to demo all 28,000 of these components today, but we'll see a few, and hopefully be able to, get a good sense of why this ESM coverage is actually super interesting for the enterprise.
Yeah. So just to give the background on the current Pro availability and comparing that with the maintenance lifetime. So Ubuntu, we currently have 4 LTS releases that are in active maintenance. 1404 at the top of the list, that went into end of life for public maintenance in 2019, April last year. And so if you're on 1404, and you should be aware that you're not getting security updates anymore, but worry not, you can get security updates through 1404 Pro. Come and talk to us about making the transition, or select 1404 Pro for your new VMs that you're launching. And for the other three, 1604, 1804, like huge releases, like lots of people using those still, and 2004, which has just come out. Those were providing, again, 10-year maintenance on 1804 and 2004. Yeah, it's a good asterisk on that, actually. 1404 and 1604 come with 8-year lifetimes only, but the end of life is still far enough into the future that it's easy and perfectly tractable for people to plan out how that migration is going to go. Anyway, to find out what release you're running, if you're on a machine and you don't know what it is, LSB release will tell you that. And this is an example of a booted up VM that's on 1404 LTS.
That's great. And so if I have, let's say, 1604, and I'm using components from Universe, let's say I have to install something that was fetched from a Universe repo. Does this mean that in 10 months from now, LTS is going to be EOL, and I have the option to move to Pro and continue support through 2024 for those components?
Yes, for sure. And in fact, what's an interesting point you're raising about Universe is that Universe isn't really security patched in Ubuntu, right? So Universe is basically its best efforts. But with Pro, there's an SLA guarantee that we will security patch, and there's more about that 2 slides down.
All right, let's keep going. What about kernel?
Okay, so kernel-wise patching. One of the things which is really interesting about the kernel is that it sees lots and lots of security research, and lots of vulnerabilities are published for it. And so the update cycle for the kernels is really relentless. We put out a new kernel build every 3 weeks, and we expect every customer to update to that kernel binary at the time of release. Now, of course, that's a lot of update, a lot of change. People that have to go through requalification, and even just the process of rebooting the VMs could be quite painful. And so people that have large estates or workloads that are particularly sensitive to uptime, like databases that require resyncing and so on, this requirement that you reboot the kernel so often, like once a month basically, to make sure that you're protected against security vulnerabilities is a big deal. And so with Pro, we've included kernel live patching. And what that does is that it applies security fixes to the kernel without requiring reboots. Technically, they're provided as loadable modules that go in and change the kernel call graph to implement the security fix without requiring you to go through the full boot cycle. And that means that your workloads, your processes that are running on top of that kernel can continue running unchanged. It's a really big deal. Customers that have big fleets were champions for this feature about 5 years ago. We put a lot of work into building it out, and here we're providing it with Pro built in. I think you have a demo around just to show application of a kernel patch and running with a VM with that applied, right, Suzy?
Yeah, we'll look at the output of the commands, and I have more questions, so I'll keep sending those questions your way.
All right, excellent, for sure. Okay, and in this slide here, we're talking about ESM, which you alluded to before. It's this concept of being able to get security coverage for everything that ships from the Ubuntu archive. So no matter whether you're using it from main, which is what is security patched in Ubuntu, or Universe, which is not. With Pro, that promise covers everything. Every archive that we're shipping components for will provide you with security fixes. This is a big effort that we put in, putting together a security team of dozens of people that were basically real upstream contributors that understood how the open source security movement and process worked, and they've put in place a lot of good process to both track CVEs and then patch, backport, and update these packages. And so we have now lead customers that are enjoying the security of being able to pull any package from any of our archives and getting guaranteed CVE coverage for them.
Yeah, apt install is so powerful. We see tons of customers that as they deploy in public cloud, they use any kind of automation, and we'll see a few of those approaches today to just fetch from just amazing open source ecosystem solutions that are out there. But then, of course, the question of that software supply chain security does come up. You have tons of ecosystems here that allude to, let's say, the library ecosystems of Python and Java and Node and whatnot. Do you have any more specifics on the coverage for some of these ecosystems?
Yeah, I mean, we have some of the logos here highlight that. It's an interesting problem, right? Like, Universe is so big, like 26,000 sources in Universe. It's hard for people to understand exactly what that is. We get asked the question, what's in Universe? And I say, well, it's called the Universe because pretty much everything is in there, right? There are databases, graph databases, message queues, and perhaps most importantly to people that are thinking about including open source as part of their developer processes, there are all the ecosystems for Python, Java, Node, and then stranger things like Ruby, Erlang, etc. You developing in any modern open source language, you've got thousands of components in Universe, and you can install and use those with the confidence that Canonical will provide CV updates. And I think it's really a game changer. I think showing it will make it material for people, and then I think we can dig in the end about how big that is and what that means for each of the individual ecosystems.
Okay. Well, let's do that. Let's just switch over, if you think that's fine, to the Azure portal. Today we're going to be using a mix of the actual portal in the browser as well as Cloud Shell, which is also integrated in the browser. If you have access to Azure, you can sign up to a free trial or free account. You can follow along using Azure CLI, using your own shell, using WSL, from your Ubuntu box. We're going to be doing some interesting things today. What do you think, Kiko? Should we get started?
For sure. Let's take a look at what Ubuntu Pro packs in.
Yeah, all right. So I'm going to be using the Azure CLI here in Cloud Shell. I already know that Canonical offers a number of images. I can list them out. By default, I'm going to be shown server 8, for just at this time, but I can use --all to get a kind of long JSON output of all the images that are offered by Canonical. In my case, I already have outputted this. I'll show you just very quickly here. I have this JSON with all of these images, and I can grab for things like 2004, which in particular is something I'm could be potentially interested in, and I get several daily images. I can look for Pro as well, which is in particular what I'm looking for. And I have a couple kind of builds here. I can use this entire URN as an alias to just quickly point to a particular build and create a VM right here from the command line. I can do a couple things. I'll do a couple things. I'll just create a regular VM. So in order to ACVM create a virtual machine, I have to put it in a resource group, which I have previously created. I have to indicate the location. There are several regions where you can deploy an Azure VM, and I have something, hopefully time permitting, I can show you at the end around regions and locations where you can deploy Ubuntu. I'll put a name. I'll just name this whatever, and I'm going to use the Ubuntu LTS image, and let's talk about custom data. I'm just going to go ahead and create this image, but I will show you this custom data in just a second. So the command has return, and if I look at this Cloud Init kind of blurb here, you see that the AC command, the Azure CLI, takes Cloud Init custom data. In this particular case, I'm telling it to install some packages like Nginx, Node, the Express library, and NPM. And then, I write a little application here that just says hello world from a particular host name. It's going to be listening in an internal port, and then Nginx is going to be proxying back to that. As the VM boots up, it's going to start Nginx, and I'm going to run this application. Again, I didn't have to specify a lot of information on networking and whatnot. This is just the kind of easy create scenario. I can then just go ahead and do more things through the portal if I minimize that. For just a moment, I can look for this particular VM that I created as soon as it comes up live here, and I'll show you in this example how you can set the networking. You can look at the metrics. You get information from the VM. Not just networking, but you get actual metrics. You get information about the kernel. It knows it's in this case it's a Pro 2004 VM. This is going to come in handy in the future. I'm going to show you a couple interesting things. And here in networking, for example, here's where you would do things like, hey, let's open port 80, like I've done here in this case. So I can, quickly query that web application that I have there. In this particular case, I'll just go ahead and copy that IP, and we can either just, go here and say hello from host BO97 in this particular case. All right, so I create a Pro 2004 image. I also created another server. I have a collection of VMs here in this subscription. At any time, I can just list the IP addresses if I need to. Working this particular project, I have a number of VMs, and I can just start SSH into them. As you probably noticed, I didn't have to specify usernames. I didn't have to specify SSH keys or anything like that. It just chooses some sensible defaults. But of course, in backend, there's an API that lets me do some more powerful things. So, again, just to reiterate something interesting here, we've just installed Node and Node Express and NPM in this Cloud Init custom data file. These things are, I need to track these things, and I'm going to be showing today how as you grow your Ubuntu Pro deployments in Azure, We give you observability. We give you the tools to be able to tell, where these things are happening, where these applications, these libraries, these packages are being installed. So to give you another example, I'm just deploying individual VMs here. But what if instead of just creating a number of individual VMs, we create a scale set? A scale set is basically a cluster construct on Azure. There are many ways to build clusters and distributed kind of systems in Azure and implement them. Scale sets is just one of them. But it kind of it lends itself very nicely to Linux images and to Ubuntu Pro in particular. In this case, for example, I would be, instead of creating a VM, I would be creating a VM scale set. I can name it, put a location for it and whatnot. But, you see all the arguments are the same. It's same image, name, same custom data file. And so the same things will happen, but now it can happen at scale. It will happen by default, in multiple instances, and then I can scale that out or scale that in as I need. And I can even define, how the upgrades of the nodes are going to happen and all of that. So, doing it with an Ubuntu 18.04 server image, is possible. It's certainly possible and fun. But, I thought it was interesting if I also did something with Ubuntu Pro. So here's a Pro Bionic image, and I'm just going to create a new scale set. And again, I'm just going to use the Cloud Init file that I've been using before. So in this particular case, instead of deploying a regular VM, I'm going to be deploying a scale set. So once that deploys, how's that going to look like? Let me just show you. So I have a couple deployed here, but if I look at this scale set right here that I deployed with Pro 2004, it also has kind of like an entry point IP address. But if I go to instances, I'll see that there's actually two VMs that are running here. They operate as parts of a cluster. They are supposed to look the same, to do kind of roughly the same kind of things, but then it's networked and architected in a way that's going to give me resilience, when I need to upgrade, when I need to do, things like patching, when I need to take them offline. The entire scale set is going to behave as a single system, and that's pretty powerful. Now, something interesting is that I can go here where it says scaling and say, hey, instead of an instance count of 2, that's not fun. Why don't we go ahead and do 50? And then you save that. And then just the number of instances is going to grow. It's elastic, and then it can come back down if I ever need to. And then I can use, of course, auto-scale mechanisms. And I'll tell you why auto-scale is interesting in just a minute as we move forward with some of the demos. So something I can show you is, I'm just going to stop this. I already have a scale set that's responding on this endpoint, and it's the same demo I had before. It just says hello world from host, but now you see that the host name is no longer ped. It's kind of cattle, and I have 2 of them, and so these are kind of load balancing a little bit. I can do session affinity. There's some fun stuff I can do here. But something perhaps interesting is if I go to that scale set now, and I didn't scale the right one, I scaled a different one. So let's just scale this up.
Yeah, you created SS05, right?
Yeah, you're paying attention. Thanks, Kiko. So we're going to go up to 10. And, this, of course, is doing all the hard work in the back end. It's deploying new disks, it's provisioning new virtual machine. It has to pipe all the networking. Something fun and interesting that sometimes people like to hear is that all of this networking in the back end, all of these packets that are entering and exiting Microsoft data centers are actually going through Debian systems that run in our top-of-rack kind of networking equipment. So we have close cousins there to Ubuntu, and that's pretty fun and pretty exciting. All right, so this will start scaling, but I'll keep going and show you a couple more interesting things because I've been going back and forth between.
Jose,
yeah, go ahead.
Just a question on this one. So the load balancing gets set up automatically. Is that how it's done? Like when you set up a scale set, like how do you know what is the endpoint for that scale set?
Oh yeah, when I create the VM scale set, I just didn't let that command finish, but yeah, it will give me a public IP. So here's how it's how it works. I have an IP configuration. This is what I can assign to public IP addresses and all of that. And then I have inbound and outbound rules, and I have the load balancer configuration. I'll just show you if I go here. Or just this one that's created. And so this tells me there's a front-end IP, which is this one I'm curling. Then there's a backend pool, and then this backend pool is managed. In this case, it had 2. Now it has 12. It's creating all these new ones, these 2 plus 10. By the way, this also does some over-provisioning as well. There are some interesting heuristics that we apply here just to anticipate that you might be needing more capacity and, just sort of, wait around for new VMs to be created. This is something fun because sometimes you might be asking for 10, you're actually getting more, but only paying for 10, just as a way to have some kind of warm capacity there waiting for you. So it's creating all these new ones.
They're kind of like warm, right, for you. Yeah.
Exactly. And then there's this load balancing rule again for 480. In this case, you can create an inbound NAT, which you might want to do if you want to do SSH. Actually, this is what this is doing. It's creating high ports for SSH for each one of these instances if I ever need to go, mostly for troubleshooting or debugging. It's not for production. Right. You don't want these instances to start, drifting from each other, and that's something that Skillset will help you do. All right, so now I'm, see that's starting to get some action here. The new VMs are coming up, and in a few minutes it will converge, and I'll show you how that looks like. But I've been going back and forth in these demos between creating single VMs from the CLI, creating many VMs in the form of a Skillset from the CLI. I just wanted to make sure that it's also very easy to do it from the portal. And I wanted to show you something that we've been working on recently that you might be interested in.
Yeah, it's my favorite feature.
So right here from the portal, just to reiterate, if you search for 2004, you're gonna be able to deploy Pro and Server right here. I'm just gonna choose this one because it has the logo and it looks pretty. I'm just gonna go ahead and create a new virtual machine, and I'm just gonna name it and a region for it. It's I'm just gonna take the defaults. But you see something interesting here. It says Authentication Type Ssh Key. Before you used to be, you were expected to kind of have an SSH key and just paste your pub key here. Now we can generate one for you. I'm just going to put my username, say, hey, generate new key pair, because I'm clicking on SSH. Is kind of assuming that I'm going to want to SSH. And literally, if I just click this blue button, I'm good to go. And I'll click it, but I want to also show you something interesting here. If you go here to Advanced, you have the same custom data and cloud init functionality you have in the CLI. You have it here as a box, so you can just copy paste your cloud init custom data right here and just get started pretty quickly. I'm not going to do anything there, but I'm just going to go ahead and click the blue button. And you might be wondering, hey, where's the key? You were supposed to kind of create one. Well, here it is. It says you can download a private key and go ahead and create a resource, and it's going to go ahead and download it to my machine. And now the VM is being created. And I can just right from my terminal, I can just SSH with that key. Or another interesting thing I can do is I could try and do it from Cloud Shell. I'll show you that again in just a second. Oh, by the way, here's the Skillset. Now you see that it has more diversity. Some of this 10 hosts are now replying in load balancing fashion. And again, I can customize a lot of things, timeouts and retries, health probes, and all that kind of stuff for the Skillset. And like I said, it's just one way of doing a cluster with Ubuntu and Azure. There are many others, including supporting, what you might already have on premises today. Often I hear from people that want to do things like pacemaker, heartbeat. They want to do the same thing they've been doing the last 10 years that is known to work. Sometimes people want things like shared disks. That's something we have now in Azure. So it's a very exciting kind of set of things you can do here. I'll stop here and see if you have any questions or comments, and also give an opportunity for people in the audience to feel free and ask questions. We're going to be looking at that towards the end of today's session.
Yeah, and in fact, I'm going to start just by picking out one of the questions there. Will this webcast be recorded? Yes, for sure. In particular because Jose and I may be going too fast, and some of the detail may be missed. So for sure, you can. It will be recorded and made available, and you can go over it afterwards and check on the demo. So Jose, I wanted to ask you a bit more about like what you did in Cloud Init there. So Cloud Init is super powerful, right? It's something that Canonical pioneered over 10 years ago now, and sort of built as a standard for how you can customize a new VM instance that's being created. And so Cloud Init basically lets you do whatever you want, really, right, as part of instance startup. And you can, as in your example, you install packages and so on. How would you recommend people leverage that for basically simplifying the deployment and management of medium to large clusters of instances? Like how does Cloud Init play into that? Like what would you typically do there?
Yeah, no, great question. I mean, I declared packages that I wanted to install. I seeded files, not very, not a lot of them, and not, binary files or anything like that. And then I kind of wrote some commands that I wanted to run. There's this fine line or gray area or, overlap area between config managers, desired state configuration, things like Cloud Init, provisioning tools. People might ask, when do I do this versus just baking my own golden image? Those are all valid questions, and what we want to do is just make sure you have the right tool for the job. In some cases it's going to be Ansible or Terraform. In some cases it's going to be Packer, and you're going to be working heavily on that disk image. And in some other cases it can be Cloud Init. I think Cloud Init it's very agile for early provisioning, for just ensuring that right from the get-go, the VM is doing what you expect it to do, rather than eventually converge, when it can reach a server and fetch a manifest and do all of that stuff. That might be useful for long-running instances in production. But if you're doing batch processing, if you're doing short-lived instances for certain use cases, and as a reminder, we also have spot instances in Azure. And Ubuntu is just ripe for that scenario. It's with just a few minutes of running an Ubuntu VM on Azure, you can do tons of stuff. If you're also automating with Cloud Init, I think that's fantastic. And this is a VM I created where Node is already running. And you can go. You can probably also, if I haven't checked, but if you do something like this, you should be able to get some of the Cloud Init output. Where you can see, where it went and fetched Node and Node Express and all that stuff. So yeah, Cloud Init also works, is very well integrated with the Azure Linux agent, which is available by default in a lot of these images. So they understand each other, they work with each other to make sure that you get information about the VM and all of that. So I always encourage people to consider, whether Cloud Init can help with your automation needs first. And then, definitely people will have different needs, and we support many other tools as well.
Right.
All right.
And in your example there, one thing to call out is that Node and NodeJS, they come from Universe in Ubuntu, and it's an interesting example of a place where you will get security updates for your Express application that you wrote. And it's kind of amazing you put the actual source code in Cloud, and it just shows how versatile Cloud Init can be. And I think just wanted to call out that those components there are going to be security patched as part of Pro. So as that application runs and as security vulnerabilities get reported, they'll get applied automatically, and you've got security built in.
Yeah, definitely. And I wanted to ask you something. So here's an Ubuntu Pro 2004 and I run this command, UA status, and I get this output. Can you tell me a little bit what this means?
Yeah, sure. So I mentioned at the very beginning, right? Ubuntu Pro, in some ways, it really simplifies the process of selecting and buying the services, because it basically comes with all the services already entitled as you boot up. So as you boot up this instance, it can already request Common Criteria EL2 certified packages or Fips packages, which are there in the list. You have live patching, which is not only available but pre-enabled on Pro. You have ESM, both for apps, that's Universe and Multiverse, and Infra, that's main and restricted, like those are the components and archives which it covers. And those are also enabled by default. And then there's CIS Audit, which is in a preview at the moment. As soon as they make that available, it's going to check over to Entitled Yes, and you'll be able to also use the CIS hardening tools in Ubuntu Pro. But UA status basically shows, for this instance, which backend services have you enabled. And in this case, you're running Pro, it's pay-as-you-go, and so there's no validity. That's why it says valid until NA. And it's at the same level of technical support as Canonical's Ubuntu Advantage Essential tier. So that's how it maps. Pro maps to Ubuntu Advantage Essential. And it comes with these services pre-enabled. So LivePatch shows that yes, LivePatch is enabled. If you query the LivePatch agent, for instance, then it will show you that it is actively tracking patches. And if a new vulnerability is reported and will publish a module that gets downloaded basically by your instance. In this case, I think it's you just booted up this instance, and so it's been booted up with the most recent kernel. If this is a long-running instance, if it's running for more than a month or 2 months, then you will have, in that case, 1 or 2 kernel updates respectively to pull down. And in this case here, you would not have to. Canonical LivePatch, the agent in the background automatically detects, hey, there's a new security module available. Let me pull that in. I'll apply that, and then you protect it against the vulnerability that was reported. So that's one of the examples of things that are built in. The ESM piece and status that you showed, that's kind of transparent to the end user. The end user is happily installing away from main and universe, and in reality, if there is a vulnerability reported against a universe package, then that will show up in the ESM archives. They're already pre-enabled, so if you look at the apps configuration, you'll see that there are ESM archives that are activated there, and as soon as a vulnerability is addressed, you get a new package published. Your instance, if you're using unattended upgrades, again, will pull that down automatically and will apply the fix for you. And if not, then you can just use your own update management. An example is basically Azure update management to do that, and then you'll basically pull down the packages that address the CVE. So that's basically just shows how in Pro, like, you get this concept of security built in. Anything that you'd have to do manually is done for you, and the scope of coverage is very, very broad. It's the broadest in the industry. Like, no one else covers as much software as Ubuntu Pro does.
Yeah, that's great, and you know, it's certainly reassuring when you're running applications. Like in this case, it's a Node application. It could be Python, it could be Java. I actually want to show you a Java one that our colleague Sean put together. But I also want to talk about Fips, because that's another interesting thing you mentioned. And
that's
that it's certainly new for me in many ways. I did deploy an Ubuntu Pro Fips-enabled image on Azure right here. One of the things that I noticed, right off the bat, is the availability of this Fips-enabled procfs flag, and also that, of course, that's something you put in the kernel boot command line. But I wanted to understand, first off, the kernel, obviously, in the other case, I showed a kernel that is -Azure. This one's -Fips. And I also wanted to ask about full stack Fips compliance. What happens with, for example, things like containers? How do we go about that too?
Cool. Okay. So first, what is Fips? Fips is it's a standard that's run by NIST, the American National Institute for Standards and Technology, and NIST specifies in Fips a set of crypto algorithms and modes for use that are acceptable. And Fips is normally attached to certifications. The most common one is FedRAMP, and so customers that are providing services to the federal government or want to qualify for FedRAMP for any other reason are required to run Fips crypto on their instances. And so this requires the OS vendors to go through a long and somewhat expensive process of certification with NIST through auditors. Basically, we take the sources that we generate for Ubuntu, we modify those sources to ensure that they only include and only enable the crypto which complies to Fips. The spec name is 140-2, the current spec name for Fips. And once those components have gone through certification, they're returned to us, and we provide that to customers. And so this is an image. The important part about Fips is that you are getting components that are different from what gets installed by default with Ubuntu. And those components have to be installed and enabled for you to be able to be Fips compliant. If an auditor comes in, they will want to check, okay, show me, is the kernel that you're running, is it Fips certified? Are the components you're running Fips certified? And so then I'll just take a quick detour into the world of crypto and dynamic libraries just to give that a bit more color. But here you have an instance that is running. That instance was pre-configured with the Fips modules, and so as you notice, you boot it up with a Fips kernel. That's a requirement for Fips. Anything that runs on an instance requires to have been booted on a Fips kernel, and that has an implication for containers. I'll talk about that also in a second. And once that Fips kernel is running, an instance requires to have been booted on a Fips kernel, and that has an implication for containers. I'll talk about that also in a second. And once that Fips kernel is running, then it means that the kernel crypto that you're using is Fips compliant. Now, most components in Linux don't use the kernel for crypto, right? They use something called libSSL or OpenSSL. There are other alternative libraries out there, but the most common case, if you're thinking of Apache or Nginx, for instance, curl, wget, SSH, they all use libSSL, which is OpenSSL is the project name. And so Canonical also provides Fips compliant SSL, and that means that any program that you're running that uses a dynamic library is also, again, Fips compliant. It only uses the crypto, which is approved by Fips. You had a question about containers. So containers, in order to be Fips compliant, they need, of course, the Fips modules installed into them. And if you're building, for instance, a Docker container, you can use Pro to put the Fips libSSL and curl and OpenSSH in there, for instance. But that container has to be running on an instance which it has been booted up in Fips mode as well. So those are basically the two requirements, that you have the Fips components in there, and then you also boot it on a kernel which is running in Fips mode. And you can check Fips mode by the presence of this procfs node, as you said. That can go from 0 to 1. When you boot up the kernel, you specify what Fips mode it is, and you say Fips equals 1, then you get Fips mode. And again, as I said, it's a special kernel binary. It's not available on the standard Ubuntu kernel binaries. It only comes if you install Pro, and from Pro you opt in for the Fips kernel to be installed in the Fips archives.
Yeah. I also love this kind of simple way to, of course, as you know, Ubuntu and Debian sysadmins would know, there's app repos involved here, and so the way you need certificates to authenticate with some of these repos to fetch the bits that have been built for Fips or the ESN bits and all that stuff. And it's good to know that there are simple techniques, like in this case, this container. It's just bind mount of etc apt, and that's where I have certificates, for example, and then that just makes it super simple for me to then just be able to tag this container image where I already have that kind of bind mount, and I already can have an updated manifest, and have, for example, RNG tools, and I know that as soon as I can test for that procfs node and know about the kernel, then my container too can kind of run knowing that it's running in a Fips-enabled environment. So that's pretty cool.
For sure, for sure.
All right.
And it's cool that you shut off the RNG test as well. It's a really cool way for you to check, okay, am I running Fips and how fast is it? So thanks for that.
Yeah, and something you might have noticed now, shifting to something else in this VM when I logged in, it outputted that, hey, the best cloud stack secured by Ubuntu Pro in the Azure cloud. That is a simple addition to my Bash RC, which is this Java app that our colleague Sean put together. And, this is a good example of, I might have it here. Okay, there's a POM.xml file somewhere here. Yep. There you go. So it's using this libraries. I built it with Maven. It's running here. But this is an excellent example of, what happens if I now kind of look at where did this library come from. And I wanted to ask you this. Look at app sources here. Now it tells me it comes from a slightly different repo. Does this mean that this potentially obscure, library I don't know much about, but that every time that I'm, starting a Bash session, it's running something that touches it? Does that mean that I'm covered by ESM?
Yeah, that's right. So because you're running Pro, the ESM archives are activated by default. And in this case here, you apt installed this Java library, Jackson, and Jackson is available and is covered by the security patching in ESM, so that's included in, and any Java module you install from the from Universe basically is ESM guaranteed. Now, in this case here, I think that what you're showing us is that this has actually been patched in the ESM archive. So if you show this, for instance, and Madison, you see that there are two versions available for Jackson, and those two different versions, one of them is the original version that came from the Universe archive, and one of those versions will have come from the ESM archive, meaning that that's already been security fixed. So they're already exactly, it's as it shows in the version string, right? It came from an ESM archive, so it's already been CVE patched, and that's basically the sort of reiterating the guarantee that comes. You're going to be using lots of different modules, right? If you're programming in Java, JavaScript, Python, Ruby, PHP, you're pulling all these modules from Universe. With Pro, those modules will get security updates. Today, anyone is either ignoring that or they're having to track all the security manually and pulling from GitHub and backporting. In Pro, we do it for you. That's a really, really solid promise, and we expect this is going to change the way that people do application and open source security in general.
That's pretty cool. And, as I mentioned, when you start deploying fleet, clusters, whatever you want to call them, but you're going to have many of these instances where you can potentially, do things with app, through Cloud Init, through Ansible, through whatever that is. It's good to have insights into this stuff. And something I wanted to show you is how we can use something like Log Analytics here in Azure for, for that. I have a workspace here where I'm feeding some of metrics and logs from several of those VMs that I've created. And one of the things I can do that is kind of simple thing to do is logs. Log Analytics is something that allows me, for example, to look at vulnerabilities that are not patched across my Linux fleet. I already have created a query here to updates available for Linux machines. So I have a table here called updates, and I can look at anything that has update state needed, and I can summarize by computer, name of the component, in this case name of the package, and version number. I'm just going to go ahead and run that, and I'm going to get a list of things across several VMs. There's actually 148 records, so there's 148 things I need to do in terms of policy compliance and whatnot. And I see in some of these cases it's kernel, which is fantastic to know that kind of live patch has my back there. In other cases it might be some low-level user space things that net plan, it's kind of still important. In other cases it will be libraries, and it's good that we also get information about that. So that's something I can do to query, and I can change this query. I can do, let's say, to kind of get a sense of where I need to, kind of prioritize. In this case, that Fips machine that's been running the longest here, and perhaps it's actually 1604. So it has a lot of things I need to act on. But it's good to know I can definitely fetch from there. And another thing, if you're less interested in logs, and you can do things like syslog events and all of that. That's all available there. But another one is metrics, which I thought was interesting. Is in this case, let me see if I can pick. I was trying something earlier that I thought would be fun. We could do a telegraph here now. Okay, so in this particular case, with metrics, is basically performance counters, and a lot of that is what you would expect that the hypervisor knows, things like network and, CPU, memory, etc. But there's actually something pretty cool. You can submit custom metrics, and something pretty cool with Telegraph that works just out of the box in Ubuntu and pretty much any release. That is, you just install the package, the deb, and you get automatically pretty much any input plugin of Telegraph you can output to Azure, and kind of look at the dashboards and all of the metrics and whatnot, right from within the portal. So you can do things like, Nginx or Postgres metrics, or for a lot of commercial products there are good Telegraph plugins available as well. I wrote a simple one for PSI if you're looking at like a specific kind of enhanced system load metric you want to look at. So that's a lot of kind of interesting things you can do. I was filtering for... Yeah, go. Yeah.
A question on that. Like in terms of VM setup, like how do you ensure that the actual metrics and logs are getting shipped back? How does the agent do that for you?
Yeah, well, as I said, there are some things that the platform just knows because, we can look at CPU utilization, memory utilization, etc.
Yeah.
For things that only the VM knows,
hypervisor.
like, from the hypervisor, but things for, like Nginx metrics or Postgres metrics or slow queries and that type of stuff, then you have agents. The Azure platform can already leverage things like the Azure Linux agent, which is open source, Python-based. It comes enabled in the Ubuntu and Ubuntu Pro images. It can just work with that agent to either fetch the metrics or provision an extension that knows how to fetch the metrics. There's a lot you can do by on default here. A lot of data, IOs, QDEPs, that type of stuff, which is interesting because you ask about Cloud Init, and that's another interesting example of its performance. It's basically performance customization. What if you just want to, change the I/O scheduler for a particular data disk, or you want to change the queue depth in a particular data path? You want to change read-ahead parameters for your Cassandra. A lot of times those are simple things you can just, with Cloud Init, just ensure that right before any installer runs, right before any cluster membership decision is made, you have the right kind of performance settings there. And again, you can feed that back here in terms of reporting, dashboards, alerts. If you want to page teams, if you want to make auto-scaling decisions, that's the value of funneling all of those performance counters and log events into the Azure platform.
Makes sense.
Something else is there are a couple more things I wanted to show you today. It's been fun and fast-paced, and we've been running the meters here a lot. There probably is now, I'm going to calculate about 250 Ubuntu Pro images running in this subscription.
Yeah, exactly.
So it's going to be fun for whoever has to pay that bill. But I want to show you a couple more things. One is identity. So here we talked about SSH keys. Whether you want to you want Azure to manage those for you, whether you want to provide your own. That's just the way we Linux sysadmins are kind of used to dealing with all of this. But there's also the identity of the VM itself. What if the VM itself has to do things in Azure and has to kind of have an identity? That's something we can do in Azure as well. So I'll give you this example. In this VM, there's going to be here a section that's called identity. And you see that it says system assign, and then it's on. It's basically assigning an identity to this VM, which means now VM97 becomes almost a user of kind of my directory and can do things in this subscription. I can actually assign roles. In this case, I've previously assigned a reader role, which means that this VM is going to be able to read, to fetch, to get information about the resources that I'm running on Azure. Now, what do I do with that? As you can see from this tab here in the portal, you can do much more. You just enable it, kind of assign a role, and pretty much that's it. But what do I do with it now? So here's something interesting that people might want to do that I thought it would be fun to talk about today, and it has to do with automation as well. Sometimes, when we are coordinating VMs among themselves, they need to do things like find out each other's IP addresses, or find out location of each other, or find out that type of stuff. And I think in this case, it's something we can do through the Azure CLI. So I'm going to log into one of the VMs that I have created. And in this VM, I do not have the Azure CLI. I could install it from the repos, because that's available in the Ubuntu repos as well. Or I can fetch it with pip and put it in my virtual env, which is what I've done here, and then just use it from there. It just keeps it clean, keeps it contained. That's always kind of a good practice to do that. So I'm here in my CLI environment, and here I do have the AC command. And what I'm going to do, what I would normally do, is I would type AC login. AC login is going to say, great, open your browser and, log in there. And that basically is going to enable you to go through the MFA or whatever it is, your corporate standard. And then your Azure CLI is going to get a token. And that's basically going to be valid for a certain period of time. And you can start doing operations with whatever role your identity has assigned to. In this case, it's a VM. In an interactive fashion, I'm not going to be able to log in, type passwords, go through MFA or anything like that. But I have just assigned an identity, and I can literally just say -- identity. And what will happen here is that it says, okay, great, well, it looks like I have an assigned identity, a system assigned identity. I'm just going to kind of, put that in my little kind of workbook, which it does here in this Azure kind of profile. And what can I do now? Well, I can read. That's basically the permission I've assigned. And in this case, I can get a list of the VMs. The same list that I'm getting in my regular kind of Cloud Shell when I'm getting the list of IP addresses or VMs. But I can do it from within the Ubuntu VM. And so AC login -- identity, something pretty simple I can put in my Cloud Init. So that then any user of that VM in a cron job, in a batch script, whatever it is that I'm trying to do, I can, through the Azure CLI, just quickly interact with Azure and get information about the other VMs, where they are, what their IP addresses are, and all of that kind of stuff. So that's something pretty cool and interesting you can do here. If you assign a different role, like creator or like contributor, for example, then this VM can spin up more VMs. You can spin up CI/CD. You can spin up, for security purposes, you want to run something in some form of sandbox. You can do that kind of stuff, and then the automation becomes more and more interesting. Now, there are easier ways to kind of achieve some automation goals. Something that's available, I'm just going to exit this. Something that's available is instance metadata. So this is another way to do kind of introspection, right? And so in this particular case, you can just curl against this well-known and metadata endpoint, and you're going to get JSON back. You can get text back as well. You're going to get JSON back that now tells you a lot of information about yourself. It does not use any kind of identity because it's just introspection. So you see this is running in Azure Public Cloud in this location. It's running this particular Pro 2004 image from Canonical. It tells you your public key. It tells you what kind of disks you have attached, and a lot of information about networking and whatnot. So that's pretty cool. One of the fields here is called tags. So this is empty now, but I'm gonna go ahead and create and assign a tag. You can do this from the command line or from the API as well, but I'll just do it here. It's fun. And so, hello webinar. And this is an easy way to help with some automation scenarios, because basically what this is going to enable you to do is, it's still assigning that, so it's going to finish in a second. It's, you can pass, perhaps not secrets, there's a separate thing for that called VM secrets, but you can pass things like sharding hints, like you can have some sort of affinity kind of rules that you can deploy to tags. And of course you can have some other kind of metadata and information.
Yeah, where that's sort of like sharding. Exactly, just based on tagging and information. Like you say, okay, these ones here are meant to be the hot replicas, these ones here are cold replicas, and these ones here are masters. So it's interesting.
Yeah, and scale sets is particularly important because you have hundreds and hundreds of these, and they need to do some coordination on boot time. So Cloud Init, system assigned identities, IMDS with tags, those are all super important tools. Several ISVs are already using that for their marketplace solutions, and you can definitely use those in your enterprise applications as well. All right, well, we're going to check back on this in a second, but I also want to show you another level of metadata you can get here, which is called attested metadata. And you know about this because you use this in Pro. But in this case, what we have is a different, slightly different endpoint. This one, instead of saying metadata instance, it's metadata attested document. And as you can see, I'm extracting a particular JSON field called signature. I'm base64 decoding it, and then this is a PKCS7 signed object. And as you can read, this is signed by Microsoft. And you're going to see information such as there you go. So you see this is an Ubuntu Pro focal. You get the subscription ID. So now this is not just information that the VM can use to get heuristics and hints for sharding and introspection, but this is actually signed data of important things, such as, we're making an attestation that this is a Pro 24 image that is running in this particular subscription ID. And I know that you use this in your activation flows to ensure that, there's information that can't be tampered with, because, again, this is signed by Microsoft, which is pretty cool.
Yeah, that's in fact how Pro itself provisions, right? It uses the signed metadata, and it can tell that VM is launched from Pro. There is, it's attached to a paid offer, a commercial offer, and that's what we send back in authorization to Canonical. Canonical then says, fantastic, this VM is paid for, here are the assets in it, and off you go.
Hey, we have a few minutes. I wanted to quickly show you two things. One is policy. What is all of this useful? We know what this is useful for in the VM for, again, things like cluster setup, authentication, authorization, all of that. But what is this good for on the Azure platform side, on the governance side of things? I have created a rule here called Audit Pro Usage, and I'm going to show you what the JSON of that definition looks like in just a second. So if you scroll down here, it says it's testing for whether the VMs have an image SKU field that equals Pro 24 LTS. In this case, I'm saying audit, but I could say things like deny. Things like, you don't deploy in this particular scope, which can be the entire subscription. It can be a resource group in the subscription for like a project. It can be a region of the subscription. You can't deploy anything other than Pro. Because Pro is giving me the ESM, Fips, and live patch guarantees that I need. So again, this is a good example of how you can use this metadata on the Azure platform side as well for things like governance. And then when you would go and try an ACVM create, a regular Ubuntu image, Ubuntu server image, it would audit that and say, hey, it's going to flag there's some usage here that perhaps is going to be out of compliance. One last thing, Kiko, we talked about regions, and we talked about all of the dozens of places where you can deploy one of these Ubuntu Pro VMs. But I wanted to show you this. This is a VM that is not running in Azure, but I can see pretty much as if it's a VM running on Azure. I actually wanted to perhaps show you. I'm going to go back here to my log analytics, and I'm going to go here to the queries. And try and run a query to show you something hopefully cool. Let's just close this, and let's say heartbeats. Trying to look at heartbeats. And perhaps the scope is not going to help me here. All right, but you can derive this from the kernel version. If you go back here, you notice that the kernel version here is not in Azure. It's actually running in a different cloud provider. And I can still get information about this Ubuntu Pro instance in Azure. In this particular case, what I was trying to show you was in the logs, and perhaps I'll be able to do it from here. I can see also performance counter, so it's pretty interesting the type of things I can do here. Oh, there you go. This should be able to help us. Okay, and so it's scoped to just one VM. Let me just broaden the scope a little bit and run this query again, and with that we'll be ready for questions. All right, so let's run this. There you go. So you see there's some VMs here that are reporting, and you see they report their latitude and longitude, and you see all of them because of really employment cool. And South Central, except for this one, which is in a different location, which is it's all derived from the IP addresses. So you can do this with VMs running in other cloud providers. You can do this with VMs running on premises. You can do this with bare metal. And you can do this also, by the way, with Kubernetes clusters, and that's another area we're working with Canonical on. But hopefully this was all cool. What do you think?
Yeah, this is amazing. Actually, I've learned so much just watching you run through like all the examples. So I really want to thank you first today for preparing this and showing us a lot of how Azure functionality can be exposed and enhance people that are running Ubuntu Pro. It's really great.
It's my pleasure.
The connection with Arc as well. I really like the story that Microsoft has put forward, that Arc is this unifying layer that can help you track assets, Kubernetes clusters, instances that are running anywhere, including on-prem and other clouds. And
it's pretty easy to generate just one script to onboard. You just kind of specify if you're using a proxy server. You just choose they're using Linux here, and then you're going to get a simple script. And even though these are shell scripts, this actually installs a dev package and then runs this command to kind of register back with Arc. So it's pretty easy to get that done. Hey,
Cool.
what do you think about going to some of the questions and perhaps talk a little bit about our security assessment that Canonical is offering on Azure for a lot of potential people in the enterprise that might be interested in that?
Yeah, for sure. Okay, so let's start with that first, in fact. With Pro, this promise of security for all of your open source is a big deal, and Canonical is offering to lead customers out there that have large open source estates that want a partner that helps them understand how to ensure that that estate is secure. We're providing you with a program called OSA, the Open Source Security Assessment. If you're interested in talking to us about it, there's a contact us link here in the webinar, and you write to us and we'll get in touch with you and set up a first conversation about how that program works. And of course in your slide here you've got a link for Ubuntu Pro for Azure. This is specifically the 1804, the Bionic link, but there are links and there are also landing pages for all of the releases on the Azure Marketplace and on the canonical.com. Yeah, it's just a simple search there for Ubuntu Pro. We'll list you all the releases that are there. We didn't mention this, but I wanted to call out that Fips is at the moment an install option on top of Pro. We're going to be providing in the coming weeks Pro Fips images that come with the Fips kernel and Fips components pre-installed and pre-activated. And so for anyone who's pursuing FedRAMP or any other certification that requires handling of government data or providing service to the government, then these Fips images are coming. And that will give you a Fips experience out of the box, like no additional automation. You can use that to plumb into your golden images and then run Fips at scale. So something which lots of customers are asking about. This is coming soon. Okay, so just because we're going to run out of time, just going to pick up on two specific questions there that I think are interesting. The first one is it possible to switch from Pro to the regular or regular LTS and vice versa, from LTS to Pro? Yes, the answer is yes. You're going to do it through the UA client that's Jose started the presentation on, so the UA client. And that also combines, I guess, the answer to the second question, which is from within the guest, if you can you tell whether the VM is Pro or not? The canonical answer to that is always the UA client. UA status will tell you everything. If you run a standard UA Ubuntu instance and you run UA status, you won't see the entitlements provision there. So that's the way you tell that. And the upgrade from LTS to Pro, which is what we're working on at the moment, is also triggered through the UA client. So those are two ways in which we've expanded how Ubuntu works. If you think about it, we created Ubuntu in 2004. The cloud didn't even exist. Like those concepts were brand new. And so the UA client is really the gateway and the portal to the connected world from Ubuntu itself. Yes, and of course you're showing out like this is how, if you were checking in the instance metadata, that's the other way of you figuring out like is this Pro or not. Then you can also check there, and the instance metadata will show both the product SKU will match the Pro product SKUs, but you can also look at the signed content, and the Pro will show up there as well. So that's basically it. Okay, we're about to run out of time. Jose, I wanted to thank you so much for help walking us through. It's amazing how much and how fast you can go through this the Azure portal and the CLI. Like it shows like years of lots of really good practice, and